here I have the Arduino Uno and I have the Arduino Mega 2560. So I think it's important we talk about the Arduino at this point, especially because in some situations we'll need many ICs and then we'll need wirings to build certain circuits. But with the Arduino, most of that is already done for us, and so we'll have enough time to focus on how electronics really behave and what's happening in the system than the plenty wiring and all that when it's not necessary. The Arduino is a programmable hardware platform, a system that can sense the environment through electronic inputs and control the environment through outputs. On the hardware we have the power pins, the 3.3 volts, 5 volts ground pins. They are used to power external circuits. And we also have VIN, which is used to supply 7 to 12 volt external power to the board. Then we have a reset pin also, which is used to reset the Arduino via an external circuit. Next we have the USB port and we have the power jack. These are main ways to supply power into the Arduino, and also data connection is additionally provided by the USB port. We have our digital pins. So these are the set of pins labeled 0 to 13. They read and they write digital signals, ones and zeros, high or low, high being 5 volts and low being 0 volts. We have the PWM pins also, and these pins are also the digital pins, but they're the ones marked with the gamma sign. They simulate analog outputs using fast on and off signals. Next we have the analog pins. The analog pins read analog input signals of 0 to 5 volts magnitude. And then we have our reset button, which helps us manually reset the Arduino. We also have our microcontroller, which is the brain of the system. It reads inputs given to the Arduino, processes the program instructions, and can respond with output. For the microcontroller in the Arduino Uno case, we have the ATmega 328P. Next we have our ICSP header. It's used to program the microcontroller directly from another programmer, especially when we're burning our bootloader. Okay, so by bootloader we mean a program that is pre-installed in the microcontroller to enable it to accept and understand every other programming we would write from the IDE and other interactions we have with the Arduino. Okay, so this is a pre-installed program. Alright, so if you have an empty ATmega 328P, okay, and you put it on your Arduino, it won't work. If you have to install your bootloader for that microcontroller, you would have to use the ICSP header to install that initial program that will enable every other program run on the Arduino. We have LEDs. We have the TX, RX, we have the L, and we have the power LED here. Okay, so we have 1, 2, 3, 4 LEDs on this Uno. The on LED helps to indicate that there is power on our Arduino. The L LED is connected to pin 13. We can use the LED for testing and for quick experiments. Okay, so we'll come to that in a minute. Then we have the RX and the TX LEDs. These are LEDs that show us when the Arduino is transmitting or receiving data from our computer. Now, next we have the IDE, which is a short way of saying the Integrated Development Environment. It helps us test and upload codes straight into the Arduino. So it's an environment where we type our codes, compile them, and send them to the Arduino for further functions. If you have your hardware, you go download the IDE software from this link. It's also dropped in the description. Just pick your OS, download and install it, then launch the IDE. So to understand the IDE environment properly, let's go to our Files tab, down to Examples, and to Basic, and down to the Blink file. Alright, we can see the sketch for the LED Blink program. Written programs are referred to as sketches for Arduino. Other words can be source code or script. Okay, so the first thing we come across here is a written note description or a comment. Okay, the way you spot a comment in an Arduino is, if it's a one-line comment, it usually begins with 2 forward slashes like you have here. So these are 2 forward slashes at the beginning of this comment. And if it's a multi-line comment, we begin them with a forward slash and an asterisk, just 1 forward slash and an asterisk, and we end them with an asterisk and a forward slash. Okay, so you put this at the beginning of your statement, and after the last line you put this at the end of the statement. Now the reason why we do this is because a comment or a note in the IDE is just a write-up we do to remind us, or to leave a reminder on our code, or a pointer to something important within our code. We don't want the compiler to execute that line or lines of information, so we put those signs to make the compiler skip those lines or that line of information. Now every sketch has at least 2 main functions, the setup and the loop functions. Okay, so if we go back to our the first file that opened, okay, this is like the, should I call it a blank file, okay, open for us to program on, or to write our programming in. Now if we look at it, we'll see we have 2 functions, the setup function and the loop function. These 2 functions must be in your code. If they are not there, then you don't have an executable code. Okay, if you look at them, we'll notice they have the word void written before them. That word void is to establish the fact that these functions don't return any value. Okay, they're just meant for execution only. They don't bring back a value after being executed. All right, so we have other description of functions that could bring back values, so the compiler looks out for the values they would get after compiling those functions. But for these ones with the void before them, no values are returned. It's just meant to only execute them. Now the setup function is meant to contain other functions you want to run only once after the Arduino starts up or it's resetted. Okay, we use them to set modes to pins and to set initial states of variables, among other things. Okay, so if we go back to our blink sketch, we'll see that within the void function we have another function, the pin mode function. Okay, and this function sets the mode of the pin as an output. We can see that. Okay, now the syntax for this pin mode function is, you have the pin mode and open bracket, then we have the pin number, and we have the mode or the value we want for the pin. Now in this case we have LED underscore built-in. If we look at this comment up here, we'll see that LED underscore built-in is set to the correct LED pin independent of which board is used. And before that we have this statement that most Arduinos have an onboard LED you can control. On the Uno, Mega and Zero, it is attached to digital pin 13. Okay, so if you remember the picture I showed just a few minutes ago, we have the L LED. That L LED is connected to pin 13, and that LED I mentioned, we could use them for quick experiments, debugging and all that. So that LED is what is being referred to here, and it's been, normally you can't just write something in your code without first introducing it or declaring it. All right, but in this case LED underscore built-in has been defined and assigned a number, all right, in the board core files. So that's why we can just write it like this and the compiler would understand what it is because it has been done already. But otherwise would have declared it before we started with our programming. Okay, so we'll come to all that, but for now what we know is that this pin mode here declares LED underscore built-in, which is the pin 13, as an output pin. And remember, this is going to run only once Arduino boots up. Let's go look at the loop function. Within the loop function we have the digital write function. Okay, and the syntax for the digital write function is pin number and the value. Okay, so our digital write function here writes the LED underscore built-in pin high. Remember here we had it written as output, but in this case we are now writing it as high. Okay, so we can actually write it to be either high or low, but in this case it's high. And then we have another function here, the delay function, which has the syntax delay bracket open milliseconds bracket close, and that goes to mean everything within the brackets is measured in milliseconds. So we have delay and 1000 here, so this 1000 is same as 1 second because this is 1000 milliseconds. And after that we have another digital write that now writes the LED pin low and then delays for another 1000 seconds. So what happens here is this loop is going to run over and over and over again until our Arduino loses power. As long as there's power on the Arduino, it will keep running this loop over and over again. So what's going to happen is our Arduino is going to turn on the pin 13 for 1 second, and after 1 second it's going to turn it off for another 1 second, and then turn it back on again for another 1 second, and just like that the cycle continues. But then if we look closely, we'll notice we have a semicolon almost after every line. So it's good to note that a semicolon ends every statement on our code, but we don't always use a semicolon. Like if you see here, okay, we're defining a function here. So for function definitions here, we don't have the semicolon. Okay, so void setup, we have the parentheses and we have the curly bracket that opens up the function. We can see that we don't have any semicolon there, but for every statement, okay, every statement we do need a semicolon. This is a statement, we have a semicolon after it. Here we do have that, here we have same semicolon, here we have a semicolon. Once it's an instruction you are writing to the microcontroller, we must end it with a semicolon. Okay, so the more you get to see more programs, you get to understand that better. So at this point we can go ahead to connect our Arduino. Okay, so after we've done that, we go to tools, go down to boards, come to Arduino AVRO boards, and we pick which Arduino we're using. Here I'm using the Arduino Uno. After that you come to the port which it's connected to and you click on it. Just in case you're not sure of what port your Arduino is connected to, you can remove the Arduino from your PC and you'll see the port is going to disappear. Okay, like in my case, I just took it out, and if you come back you see we have just one port here. Okay, if I bring it back, all right, so bringing it back, we have our port back. So after that we can click on this to just compile a code, or we click on this to compile and upload. So you see, look down here, we can see, if you look down here, we see it's compiling our sketch, and after a while it's uploading our sketch, and we can see the lights blinking on the Arduino, and it's done uploading. And if you look at the Arduino, we can see it blink for 1 second on and off. Now just to show that yes, this LED is actually connected to pin 13, we can connect an LED, an external LED, to that pin 13, and we would have it blink. And so we'll just connect a resistor from pin 13 to our LED, and from the LED to ground of the Arduino, and we'll see our LED blink.